Hello and welcome to another one of D's ADD videos. Today we're going to be discussing Coulomb's law. Coulomb was a French scientist that lived in the 1700s that basically came up with the relationship of the force between charged particles. And he was able to look at something called a torsion balance that allows you to look at charged metal spheres and relate them to a fiber and look at the force on the fiber and relate the charges on the spheres to the distance traveled. So basically, something a little bit more complex than we need to go to for our understanding of what's going on in Coulomb's law, but he used this item called a torsion balance that you can look into on your own if you're curious, allowing him to determine what the relationship is between the charged particles and the force between them, and how it relates to the magnitude of the charged particles and their distance between each other. He found that the force between the point charges is inversely proportional to the square of the distance between these point charges and directly proportional to the product of their charges. And we're going to be dealing with the absolute values of their product. The signs will not come into play when calculating the force. What is a point charge, you may ask? Well, a point charge is something that's very small relative to the distance that's in between the other charged particles. We will look at currents later, where it's groups of charges, but for right now we're looking at single protons and electrons. So what is the formula when we're dealing with Coulomb's law? The formula is this right here. The formula is K, constant of proportionality, absolute value of Q1 times the absolute value of Q2 over R squared. Okay, and this is going to be how you calculate the force between two charged particles, point charges, or more than two. We'll talk about that in a little bit. Where K is equal to 9 times 10 to the 9th, or 8.99 sometimes, newtons meter squared over Coulomb squared, or Coulomb's to the -2, same thing. And historically, you might see it written as K, might be 1 over 4 pi epsilon naught in some textbooks, where epsilon naught is a constant of permeativity in vacuum or free space. And that's equal to 8.85 times 10 to the -12 newtons inverse meters to the -2 times Coulomb squared. Again, I want to point out the fact that we're dealing with absolute values here for the charges, so we just want to quantify the force. And what will happen is a lot of times we'll be dealing with not just two charges, but more than two charges, okay? So you have to be able to deal with multiple point charges. Multiple charges are required to use the law of superposition, basically allowing you to use vectors and trigonometry to calculate the forces in the x direction, then sum them up, and then calculate the forces in the y direction, and then sum them up also. Using trig and decomposing the vector into its component parts. If you're not familiar with vectors already and pretty proficient in going into x and y components, go back and review that before you start trying to tackle Coulomb's law problems. But it's the same thing you did in mechanics and heat, physics 1, so it should be second nature by now. So basically, we're going to be using trigonometry, like I said, to calculate the magnitude. So for instance, if you remember, opposite over hypotenuse would be sine of theta. So then you could multiply whatever this vector is, in this case v, on both sides. Then when we multiply both sides by the main vector, we get what the y component is equal to. And then by using the same rationale for the x component, we would just use cosine theta. And then when you multiply both sides by v, you get what the x component is. You can do this for every force vector that's created. In this case, we're going to be dealing with forces between the charges. And then what you're going to have to do is add up all of the x's and add up all of the y's. And to get what the total force would be, you would use this magnitude formula. Okay? Then To figure out the direction, you would just take the inverse tan of the y component of the force divided by the x component. It'll become more obvious when you do a few of these problems. The key always is to practice, practice, practice as always. I hope this has clarified Coulomb's law enough for you to try a few examples, and you'll see it's not too bad once you get started and once you get going. All right? Thank you and have a nice day.